Lesson 8.1, Greatest Common Factor. The greatest common factor of two numbers is the largest number that will divide evenly into both numbers. And we can find the greatest common factor of two or more monomials as well as two numbers. Finding the greatest common factor of two numbers, we can use two methods. The first method is to list the factors. So if we find the greatest common factor of 24 and 56, we first list 24. 1 will divide into it, 2 will divide into it, 3, 4, not 5, 6, not 7, 8, not 9, not 10, not 11, 12, and 24. 56 will divide evenly by 1, 2, not 3, it will divide by 4, not 5, not 6, it does divide by 7 and 8, not 9, not 10, not 11, not 12 or 13, it will divide by 14, and then 2 times 28 and 1 times 56. Now we look at the two numbers and we find the largest number that they have in common, and that is 8. So the greatest common factor is 8. Now just on a side note, if the greatest common factor is 1, the numbers are called relatively prime. So you can just say prime. Now using factor trees, we're going to use the same two numbers and we're going to create a factor tree for each number. 24 is 2 times 12, 12 is 2 times 6, 6 is 2 times 3. 56 is 2 times 28, 28 is 2 times 14, and 14 is 2 times 7. Now what we do is we look at the two factor trees and we circle the pairs that they have in common, or the numbers that they have in common. And I like to draw a line between them so I keep track and I know I've got all of them. So they have 3 2's in common. Then to find the GCF, we take each number that they have in common and multiply them together. Now, we don't take 2 2's, we just take one set. So 2, 2, 2. 2 times 2 times 2 is 8. We can find the GCF of a monomial that has one variable. We look at the coefficient and the variable separately. Okay, so you find the GCF of the coefficient. And then you look at the exponents and you pick the smaller exponent. Now 9x and 45, 45 has no x in it, so we can't have any x's in our GCF. 9 is 3 times 3, 45 is 5 times 9, which is 3 times 3. So they have these 3's in common. So the GCF is going to be 3 times 3, which is 9. With 7 and 21, 7 is only 1 times 7, but 21 is 3 times 7, so they have a 7 in common. And here I have 2 x's and 1 x. I have to pick the smaller, so they have 1 x in common. 18 and 12. 18 is 2 times 9, and 9 is 3 times 3. 12 is 2 times 6, and 6 is 2 times 3. They have a 2 in common, and they have a 3 in common. So they're going to have a 2 times 3, which is going to give me a 6. And then I have 6 x's and 3 x's. So the GCF is only going to be able to have 3 x's. the smaller exponent. If I have more than one, I look at all three and I see which all three have in common. They all have a 5 in common. I have 3 x's, 2 x's, and 1 x, so I have to pick the smallest one, which is 1x. If I have more than one variable, I do the same process. I find the GCF of the coefficients, and then I pick the smallest exponents. For each variable. Okay, so here I have a 9 and a 15. 3 will go into both 9 and 15. It's the largest number. I have 1x, 2 x's, so I can only bring 1x. I have 1y and 4y, so I can only bring 1y. Down here I have a 9 and a 5. 9 and 5 are prime. So the GCF would be 1. But I have 3 u's and 2 u's, so I can bring 2 u's. I have 1 v and 3 v's, so I can bring 1 v. I have 1 w and 3 w's, so I can bring 1 w. And so my greatest common factor will be u squared vw. Here I have 3 numbers in common. 14, 10, and 2. 2 will be the largest number. 3 x's, 2 x's, and 4 x's, so I can only bring 2 x's, that's the smallest exponent. 2 y's, 1 y, 2 y's, so I can only bring 1 y. 18 and 30, 18 is 2 times 9, and 3 times 3. 30 is 2 times 15 and 3 times 5, so they have a 2 and a 3 in common. So that's a 6. I have 1x and 4 x's, so I can bring 1x. I have 4 y's in both. Here I have z's, but here I have no z's. So I can't bring any z's out. They would have to both have z's. So this is my greatest common factor. Factoring the GCF of a polynomial is the same process, but then we have some addition and subtraction involved. So first I look at my coefficients. They're going to have a 5 in common. And then I have 5d's and 4d's, so they have 4d's that I can bring out. But what I have to do next then is 25 divided by 5 is 5. I had 5d's, I took 4 away, so I have 1 left. 45 divided by 5 is 9. I had 4d's, I took all 4 away, so I have none left. Doesn't matter how many terms, we factor the GCF out of all of them. It has to be for all of the terms. These all have a 3 in common. Oops. Now, these two have a 2 in common, but I have to factor something out of all 3, so I can only bring out a 3. I have 4k's, 3k's, and 1k, so I can only bring out 1k. 9 divided by 3 is 3. 4 minus 1 leaves me 3. 12 divided by 3 is 4. 3 minus 1 leaves me 2. 6 divided by 3 is 2. 1, take away 1, leaves me no k's. And my signs stay the same. Here we have more. 18 is 2 times 9, which is 3 times 3. 63 is 7 times 9, and 3 times 3. And then 9, of course, is 3 times 3. So they have the 2 3's in common all across, so I can bring out that 9. 3, 2, and 1p, so I can bring out 1p. 18 divided by 9 is 2, and I have 2 p's left over. 63 divided by 9 is 7, and I have 1 p left over. 9 divided by 9 is 1, and I have no p's left over. Now you can't leave this blank. You do have to put the 1 in there because it's holding this place. 18, I factor that. 48. 56. 86. The only thing that all four terms have in common is a 2, so I can pull out a 2. I have 5, 4, 3, and 1x, so I can only pull out 1x. 18 divided by 2 is 9. I took 1x away. 48 divided by 2 is 24. I took 1x away. 56 divided by 2 is 28. I took 1x away. And 86 divided by 2 is 43, and there are no x's left. And this is how you factor out of a polynomial. Now, factoring the GCF is always the first step in factoring polynomials. So you want to be sure to practice this skill very carefully and get good at it.